Hello everyone, we're glad you're joining us for a second video on our SAT Math series. And in this video, we'll review some math facts. So these math facts you should know from school, but we'll review them because they're important to know in some SAT level questions. So the first one we'll talk about is real numbers. So real numbers are numbers that can be located on a ruler. So nearly any number you can think of except imaginary numbers and infinity can be regarded as real numbers. So that means rational numbers, integers, whole numbers, and irrational numbers are real numbers. So what is a rational number? Rational number is a number that can be written as one integer over another. And notice ratio in the word rational. So these are some examples of rational numbers: 5/3, 0.63, and 0.01212, which is a repeating decimal. So 5/3 is a rational number because 5 is an integer over another integer, 3. 0.63 is an integer because it's 63 over 100, which is an integer over another integer. And 0.01212, a repeating decimal, is a rational number because 12 over 990 gives you 0.01212, thus making it a rational number. And if you'd like to know how to convert a repeating decimal into a fraction, just let me know down in the comments and we can have a one-on-one tutoring session where I'll show you how to do that. Next, we'll talk about integers. So integers are positive or negative numbers that do not include fractional or decimal parts. So an example of an integer are -2, -1, 0, 1, 2, and so on. Now whole numbers are positive numbers in addition to 0 that do not include fractions or decimals. So for example, 0, 1, 2, 3, and so on are whole numbers. And finally, we'll talk about irrational numbers. And irrational numbers are a number that cannot be written as one integer over another. Basically, it can't be written as a fraction. So the square root of 3 is an irrational number, pi is an irrational number, and this decimal over here is also an irrational number. To continue, we'll talk about symbols, exponent rules, and roots. Alright, so we'll begin with symbols. So this symbol here represents is equal to, an example is 23 is equal to 23. This next symbol represents is not equal to, and an example of that is 23 is not equal to 25. The next symbol represents is greater than, and an example is 25 is greater than 23. The next symbol represents is less than, an example is 23 is less than 25. The next symbol represents is greater than or equal to, and an example is x is greater than or equal to 23, so that means x must be 23 or greater than 23, so it's probably 23, 24, 25, and so on. The next symbol is less than or equal to, and an example is x is less than or equal to 23, and that means x must be 23 or less than 23, so 23, 22, 21, and so on. Okay, next we'll talk about exponent rules. So here are the rule names, and here are the rules. So we'll talk about product rule first. So a to the power of m times a to the power of n is equal to a to the power of m plus n. So when you have the same base, you basically add up the exponents. And below, you can see a to the power of n times b to the power of n. So the bases are now different, but the exponents are the same. So when you do that, you just multiply the bases and then to the power of n, and you'll get the same value. Alright, quotient rule. So a to the power of n divided by a to the power of m, and notice same base, and that's the same as saying a to the power of n minus m. And when the bases are different, but the exponent is the same, a to the power of n over b to the power of n, that's the same as saying a over b to the power of n. Negative exponent, a to the power of negative n is the same thing as saying 1 over a to the power of n. Power rule, a to the power of n times m is the same thing as saying a to the power of n times m. So when you see a question that has this, always know that it's just you can multiply n times m. Alright, next is the tower rule, and that's a to the power of n to the power of m, same as putting this here and then saying a to the power of n times m. Alright, next we'll talk about fraction rules. So a to the power of 1 over n is the same thing as the square root of a, and you'd put n over here. So when you have the square root of 2, 2 would be a, and then n would be 2, so that's just the square root of 2. Alright, and then now we'll talk about the 0 rule. A to the power of 0 is 1. That means whatever number to the power of 0 is 1, so 9 to the power of 0 is 1, 8 to the power of 0 is 1, okay, and then 0 to the power of a is always 0, for a is greater than 0. Okay, now the 1 rule. A to the power of 1 is a, so any number to the power of 1 is a, and 1 to the power of a is equal to 1. So basically, let's say 4 to the power of, let's say 1 is 4. Okay, so now we'll do an example problem. Let me get my pen before we continue. Alright, so is 4 equal p squared, then 16p equals what? So here we must recognize that 4 squared is the same as 16. Alright, now let's work on this part of the question. So if we want 4 squared to appear here, we have to square this. So if you do that, you'll get this 4 squared. And remember that when you square one side, or when you do anything to one side of an equation, you always have to do it on the other. So p squared, and then we'll have to square that. But as I said, you do the same thing to the other side of the equation. So 4 squared, we know that's 16, and p squared, as we learned with the exponent rules, you have to multiply these. So that would basically be p to the power of 4, because 2 times 2 is 4. So now we have everything we need to solve the problem. So we know that 16, we know what 16 is now, and 16 is p to the power of 4. So p to the power of 4, and p to the power of 4 is the same thing as 16, and we're just replacing p with that, times p, and then always know that there's a 1 here. Like if you have 5, just know that 5 is also 5 to the power of 1. And here p is there, and it's the same as p to the power of 1. So as we learned, when you multiply numbers with the same base, you just add up the exponents. So 4 plus 1 is 5. And that would be your answer, p to the power of 5. Alright, so now we'll talk about roots. So here is the square root of x. So this means that one of two equal non-negative numbers whose product is x. So the square root of 4 is equal to 2, since 2 times 2, which are equal non-negative numbers, equals to 4. And always know that the square root of 2 can be written as this or this. Here is the cube root of x, and there are 3 equal numbers and their product is x. So an example of this would be, let's say the cube root of 8. So there are 3 equal numbers and their product is x. So that would be 2 times 2 times 2. So these are 3 equal numbers and their product is x. And x is 8 over here. Okay. Next, you cannot take roots of negative numbers. Always know that. But because doing so gives you an imaginary number. So let's say we take the square root of negative 1. So that gives us an imaginary number of I. So in the future we'll talk about this, but just know that if you take the square root of a negative number, you get an imaginary number. So this is called a radical. So the square root of 4, is equal to 2. But the square root of 4 is not equal to negative 2. So the square root of 4, the 4 is called a radicand. So this 4 here is a radicand. This 8 in our question here is a radicand. Okay, so then moving on. To multiply square root radicals, multiply radicands. So here is the square root of 2 times the square root of 3. That gives us the square root of 6 because we multiply the radicands. 2 and 3 giving us the square root of 6. To add or subtract radicals, the radicand must be the same. So let's make the radicands the same. So we know that 4 times 2 is 8. Let's extend that a bit. Plus the square root of 2. And we know that 2 times 2 is 4, so we can bring out this 4. So 2 times 2 is 4, and that's why I brought that out. Plus the square root of 2. Alright, now we can add them because the radicands are the same. So that would basically give us 2, and always note that there's a 1 here. So 2 plus 1 is 3 with the square root of 2. And that's how you add radicals. And if you would subtract, you'd follow the same path. Okay, to eliminate a radical from the denominator, multiply the numerator and denominator by the radical. So if you have 4 over the square root of 5, just multiply the numerator and denominator by that radical. So here you do the square root of 5 and square root of 5 multiplied by 4 over the square root of 5. And here it gives you 4 the square root of 5 over 25 because over square root of 25, because the square root of 5 times the square root of 5 gives us the square root of 25, and we know that the square root of 25 is 5 because 5 times 5 is 25, and that would be our answer. So finally, we'll do this example problem before we get to our challenge problem. So if 12 square root of 12 is equal to h square root of k, where h and k are positive integers, and h is greater than k, which of the following could be the value of h plus k? Okay, so let's simplify this. So 12, we also know that 12 is the same as 4 times 3. And you can bring this 4 out because 2 times 2 is 4. So 12 times 2. Then the square root of 3, that's the same as 24 root 3. So here it says where h and k are positive integers and h is greater than k, and that is why I didn't add 12 and 12 together. This is not the correct answer because we know that h is greater than k. So you might be tricked into going with 24, but just know what this sign means, as h is greater than k. So here, h is greater than k. So the question is asking what is h plus k, so that's 24 plus 3. That gives us 27. And 27 would be our correct answer. Alright, now let's get to our challenge problem. So here it says if x is equal to the square root of 3 and y squared is equal to the square root of 18, then 25 over xy is equal to what? So in this video, we've gone over the knowledge you need to do this problem. So work on it and put your answers on the comments below, and I'll let you know if you're correct. And if you're not, I'll be happy to have a one-on-one tutoring session explaining how to get the answer. So make sure you hit the subscribe button below, and also visit our website at harmonysatprep.wixsite.com/satprep, or comment below if you have a question on what we went over. We also provide free one-on-one tutoring, so make sure to take advantage of this free resource. To sign up, visit our website. We'd like to thank you for joining us, and we hope to see you on our next video.